Are you able to see the slides here? Are the slides visible to you?
Yes, sir.
Okay, then, so this is the block diagram which I had started in the previous class, and I think we had studied about, that means we had gone through what are the electrodes and what are the electrode mounted selectors, right? And the remaining part that we have to discuss is this particular amplifier part, this particular filters, and what is the sensitivity, what is this A to D converter, and what is this writing unit, right? So we have to discuss these parts. I think we had completed these parts, the electrode part and then the electrode mounted selector. So next part that we are going to discuss today is the preamplifier, right? So what is a preamplifier here? Okay, so as we know that whenever we are going to capture the EEG signal from our scalp or from the brain, so the amplitude of signal is very less, right? So as I had mentioned previously that we are getting an amplitude of 100 microvolts. If we are getting, if we are collecting the EEG signal from the scalp, and 1 millivolt if we are collecting the EEG signal from the cerebral cortex, right? So this is, if you come, if you see this amplitude, these amplitudes are very less, right? So there is a need to increase the amplitude of these signals which we are capturing from the brain, right? So what we are going to do for that, for increasing the amplitude or the strength of the signal, because the 1 minute, 1 minute, 1 minute. Okay, so coming on to the preamplifier. Okay, so what happens with the preamplifier? So we are using the preamplifier to increase the amplitude of the signal, right? The signal that we are capturing from the brain. So we are going to increase the strength of the signal. For increasing the strength of the signal, what we are doing, we are going to use the preamplifiers right here, right? So what the preamplifiers are going to do here? Okay, so we know that we are going to take the EEG signal in different channels, right? It may be 2 channel, it may be 12 channel, it may be 16, it may be 32, or it may be 64, right? So there is a, every channel has an individual multi-stage, each and every channel. That means if you are using 32 channels, and each and every channel is going to have an individual multi-stage AC coupled very sensitive preamplifier with differential input and adjustable gain. Okay, that means the preamplifier that we are going to use here, okay, that we are going to use in the EEG machine, is going to be a separate preamplifier for each and every channel. Okay, if you are acquiring the 16 channel output, then there will be 16 separate preamplifiers, or if you are using 32 or if you are using 64. So depending upon number of channels, each and every channel is going to have a separate preamplifier. Okay, if uh, if you are going to if you want to know what is the preamplifier, so just remember that we are using the preamplifier to increase the strength of the signal. Okay, so each and every channel is going to have its separate preamplifier, and the preamplifier that we are using for each and every channel will be a multi-stage. That means it is not going to be a single stage. Okay, so those who don't know about the multi-stage, I am just going to explain you what is a multi-stage. So if you are using a single amplifier, okay, this is my single amplifier. Okay, if I am using multiple amplifiers, one, three, four, like that, and what I am doing, you may connect them in parallel or cascade. Cascade means series. Okay, that means this will be input, and the output of one amplifier will be given to other amplifier, and the output of second amplifier will be given to third amplifier, and then the output of third amplifier will be given to fourth amplifier, and then the final output will be given to our system. Okay, this is the EEG signal that we are getting here, and first the signal will go to first amplifier, and then this amplifier is going to amplify it. It may be going to increase the strength, or it may be going to increase the differential strength, and then it is going to give it to the second amplifier, and second amplifier is going to further increase the strength, and then the signal is again given to third amplifier, and then fourth, and then you are going to get the final signal, right? So this is known as a multi-stage amplification. That means you are using multiple amplifiers for increasing the strength of your signal. Okay, So, and what is a coupling? So one amplifier output is 0 to second. So here we are having a coupling. Here we are having a coupling. So here what we are the amplifier that we are going to use along with the EEG machine will be a multi-stage AC coupled and very sensitive amplifier. That means it is going to acquire a very small signal there. Okay. And with differential input and adjustable gain. Those who don't know about the gain is nothing but if you are having an amplifier, so there will be a gain known as K. And you can increase this value from 1 to 100, or you may also call it as 0 to 1. Sorry, the gain maybe if you are taking in percentage, that it will be 1 to 100%, or if you are taking a constant value, it will be 0 to 1. Okay, so you can adjust the gain of the amplifier so that you can adjust the signal strength. The amplifier that is going to amplify the signal, you can adjust the strength of the signal, right? So what you have to remember in the pre-amplifier stage of your EEG is the first thing that you have to remember is you are going to use individual amplifiers. Okay, and that means one amplifier set will be for one channel, and depending upon number of channels your EEG machine is going to have, there will be that number of amplifiers, pre-amplifier stages. Okay, and the amplifiers will be a multi-stage amplifier. That means group of amplifiers are connected together, and that is known as a multi-stage amplifier. Coupling will be AC coupled, and they are very sensitive, and the gain will be adjustable. That means you can adjust the gain from 0 to 1, and then those are differential input. So what is the differential input? Okay, if the people who have studied of so they know what is the differential input. So differential input is nothing but if you want to understand it easily. So this is an amplifier, right? You are having an amplifier. So this amplifier is going to have two inputs, okay, and this is going to take the signal, which is going to be a difference between the input one and input. This is the first input, this is the second input, this is my amplifier. So the difference of the signal available at the first pin and second pin will be taken by the amplifier, and that particular different signal will be amplified by this amplifier. Okay, so whenever I am going to talk, whatever maybe I am talking in any ECG or maybe any other machine, EMG machine, so there I am going to use the amplifiers, and whenever I am talking about the amplifiers, most of the cases I am going to use the differential input amplifiers there. Okay, and what is about the differential input amplifiers? They are nothing but an op-amp. Operational amplifiers will be used as an amplifiers here. And whenever I am talking about the op-amp, operational amplifiers, these are going to have two inputs, and difference of these inputs will be amplified and will be given as output. And okay, so this is about our amplifiers. Okay, so let me erase all this stuff that I have drawn here. Okay, and then the other important characteristics that my amplifier going need that I need for my EEG amplifier is it should have high gain and low noise characteristics. Okay, that means if you whatever when I am going to talk about the amplifier, I just need to know about the S by N. Okay, which is called as a signal by noise ratio here. Okay, so the amplifier that I am going to use for my EEG application should have signal to noise ratio as high. What this means? If my signal to noise ratio is high, means my numerator will be high and my denominator will be low. So my overall ratio will be high. This directly represents that if my signal to noise ratio of my amplifier is high, that means I am going to get more signal and less noise. Okay, so that's the reason why I'm going to use the amplifier which is going to have a high signal to noise ratio, right? That means if I am talking about the signal to noise ratio, so what I am going to say here is it should be high, then only I am going to get high signal and then low noise here. Okay, also this is the second important point that you need to remember here, and the third important point here is high common mode rejection ratio. What is this common mode rejection ratio? Okay, so as I said here, I am going to use the amplifier which is going to have a differential input, right? So differential input means I am going to have two input pins, right? So this, if you are having common signal on these two pins, then if this is going to reject that, if you can able to have, that means this is not that much important. So just you have to remember that if the common mode rejection ratio is less, that means sorry, if the common mode rejection ratio is high, then it is going to minimize the interference signal. That means the signals which are going to be because of the addition. Like you are having an easy machine, right? So you are going to have an easy machine and you will place an easy machine at one place in your lab. There may be chance that some power line may go apart from the easy machine, and that power line, as you know that whenever we are going to talk about the electrical voltage in our house, okay, so it is going to have a frequency of 50 hertz, right? So घर में जो बिजली आता है उसका frequency क्या है 50 hertz, right? So that 50 hertz frequency may interfere our EEG signal, right? Because yesterday I had said that the EEG signal may vary between a frequency range of 0.5 to 50 hertz, right? So this 50 hertz may interfere my EEG signal, right? So for reducing the interference occurred by my power line, I need to have a high common mode rejection ratio amplifier. Then only my amplifier easily reject the high, that means reject the power line frequency from my EEG signal. Okay, so let me erase this and let me summarize this part. Okay, so what I had discussed is, so the pre-amplifier. Okay, so yesterday I had discussed that first the signal is going to be captured by the, as you can see here, my signal is going to be captured by these electrodes, and then this, from this electrode it is going to this electrode Monte selector, right? And here the electrode Monte selector is going to select how many channels I need. Okay, whether I need 1, whether I need 12, whether I need 16 or 32 or 64. So this is going to choose, and depending upon that it is going to group these electrodes and it is going to make the channels. Okay, and then it is going, my signal is going to move into amplifier state. Okay, so what is going to happen in the amplifier stage? So the amplifier is going to, the only thing that the amplifier is going to do here is, you know that my EEG signal is going to have a signal strength very less, so it is going to increase my signal strength. Okay, so for that, this type of amplifier I need to choose, because my aim here is to increase the strength of my signal, right? So for that, the first thing that you need to remember here is, I am, as you know that my EEG channels may vary, right? So each and every channel is going to have a separate amplifier, pre-amplifier stage. Okay, so the first thing is, it is going to have individual pre-amplifiers, and it is going to have multiple stage pre-amplifiers that two connected as AC coupled, and the sensitivity will be very sensitive because they need to detect a very small change in the signal. Okay, and then it will be differential input, and these amplifiers will have a adjustable gain. Okay, the first line here represents that itself. We are going to have individual multi-stage AC coupled very sensitive amplifiers with differential input and adjustable gain here. Okay, and the second thing here is, here you can have high gain and low noise. That means here the second thing just represents the signal to noise ratio, right? That means my amplifier should have a high signal to noise ratio. Then only I am going to get high signal and low noise. Okay, and the third important thing that I need in my amplifier is, I need to have that type of amplifier which is going to have a high common mode rejection ratio. Why? Because if my amplifier is going to have high common mode rejection ratio, then it will definitely minimize the interference signal caused because of the power lines or other electrical equipment which is surrounding my EEG machine. Okay, so I have that clear. Have you understood still this particular amplifier part here?
Yes, sir.
Okay, so this is about the amplifier part, and then after amplifier part, I need to know what is the sensitivity. What is the sensitivity? Why the sensitivity is going to be controlled here? Okay, let me arrange this. So I need to know what is this sensitivity, which I have round off here. Okay, so what is the need of this sensitivity here? Okay, so just remember about the sensitivity, because the sensitivity control is just to control the picking up of the signal here, and the next important parts are filters, noise, and then the writing part, all these things. Okay, so coming on to the sensitivity control. Okay, so for the EEG machine, if you are, as we are discussing about the EEG machine, so the overall sensitivity of EEG machine is the gain of the amplifier multiplied by sensitivity of the writer. Okay, here I am discussing about the analog amplifier. Okay, the sensitivity term will come only if you are using an analog type EEG machine with you. That means you are not getting the display on the screen, and there will be a pen which is going to plot the curve. Okay, that means Analog type means I am going to have a paper here, and this paper will move, and one pen will be like this, and it is going to plot like this continuously. Okay, so for this the sensitivity important. Okay, if you are having a digital type, then this sensitivity is not going to play any role here, because you are going to control the sensitivity in the amplifier stage itself. Okay, this sensitivity control is mainly for the pen driven, or if you are having a plotter in your easy machine, then the sensitivity will be very important factor here. You can see that in our lab also. In the lab, you are going to have a student physiograph machine. So that is going to be an analog type, which is going to plot on a graph paper. So there will be an ink pen that is going to plot. That is, it will move depending upon the EEG signal. So there the sensitivity plays an important role, because if the sensitivity is not properly adjusted there, the pen may not move synchronously according to your EEG signal. Okay, then the sensitivity plays an important role here. Okay, so what the sensitivity control means here is, it is nothing but the gain of the amplifier. So you are going to set the gain of the amplifier. That gain of the amplifier will be multiplied with the pen sensitivity. Then that will be called as an overall sensitivity of an EEG machine here. Okay, so it's the gain control. If you want to know the gain control of an EEG machine, so EEG machine having a two types of gain controls here. Continuous variable type is used to continuous variable type, which is used to equalize the sensitivity of all channels. Okay, if you are using a continuous variable type gain control, this will be used for equalizing the sensitivity of all the channels that your EEG machine going to have. Okay, the other control operates in steps. That means you will increase or reduce the sensitivity at channel by known amounts. Okay, so this is not that much important. So now let us directly move into the filters part. Okay, so what the filters are going to do here? Why we need a filter in a EEG machine? Okay, so and the last I will summarize so that you can easily remember the complete block diagram of the EEG machine. Okay, so let us move into the filters part. So what the filters is going to do here? Okay, so you know that we are going to use surface electrodes, right? So this is your scalp, so you are going to place the surface electrode on the scalp, right? So what's the problem with the surface electrodes is, along with the EEG, there may be chances that your signal may also consist of muscles. Okay, like the scalp and the neck muscles. So you are going to have some neck muscles in your neck, or some muscles in your scalp. So some EEG signal may also get the signal from the muscles also. That is, whatever the signal apart from my EEG signal, I will call them as artifacts. Okay, so if you are getting the signal from the muscle, those can be called as a muscle artifacts, right? So what is the problem means, whenever you are capturing the EEG signal by using the surface electrodes, there may be more chance that you are going to get the muzzle artifacts. Okay, so what we can do for this? Okay, that means you are getting the muzzle artifacts because of the muzzle present there. So how we are going to remove these muzzle artifacts or the noise signals that are getting from the muzzle? So how we can remove this means, we can remove this by using a filters, right? So where is my pen? So we can use a low pass filter. Okay, or if your frequency is greater than the EEG machine, then we can use the high pass filter, or sometimes you may also use the notch filter. Okay, so I will explain you how we are doing it. Okay, so I am getting some signal. Okay, so when I get this signal, this is my raw signal. Let us consider this is my raw signal. Okay, so this signal is having a EEG frequency. Okay, that is my 0.5 to 50 hertz, and apart from that, this is having, that means this is having some frequency. Actually my EEG signal is from, as you can see here, 0.1 to 70 hertz. Okay, that means I am getting a frequency of 0.1 to 70 hertz. Okay, so actually this is, they are written wrong. This is not typical frequency. Typical frequency will be 0.5 hertz to 50 hertz. Okay, so actually I am getting a frequency of 0.1 to 70 hertz. Okay, so but I know that my EEG signal will be from 0.5 to 50 hertz, right? That means I am getting 0.1 to 0.5 some signal, right? So this is my low frequency noise signal, and I am getting some frequency between 50 hertz to 70 hertz, right? And this is my high frequency signal. Okay, so I need to remove the low frequency signal, and I need to remove the high frequency signal also, right? So I think I had explained you the low pass and high pass filter when I am discussing the transducers and sensors part. Have I discussed the low pass and high pass filter there? कोई बताओ? Have I discussed the low pass and high pass filter there? ऐसा नहीं ले रहा क्या? Have we discussed the low pass and high pass filter?
Yes, sir. याद नहीं.
Okay, then I will repeat again. Okay, so what I need to do here is I am having some frequency below 0.5 hertz. So I need to remove this low frequency signal because this is not my easy signal. This is a noise signal for me, right? And then I am having a frequency between 50 hertz to 70 hertz, right? And this will be my this high frequency signal is also my noise signal, right? So I need to remove the low frequency signal. I need to remove the high frequency. Okay, so I need a low pass filter. I need a high pass filter. Okay, so how can I do that? Okay, if let us consider that I am not getting the high frequency signal, I am just getting the low frequency signal. Okay, so then I will use the high pass filter. So what the high pass filter is going to do? Okay, so let us consider that my EG signal I am getting is 0.1 Hz to 50 Hz. Okay, but I need is 0.5 Hz to 50 Hz. Okay, then what I will do is I will use a low high frequency signal or high pass filter. Okay, high pass filter. So what, and I am going to fix the cutoff frequency FC. I am going to fix the cutoff frequency for this as 0.5 Hz. Okay, then what it will do? So I am using a HPF, which is called as an high pass filter. Okay, so I am getting my signal here. So this signal is having a frequency of zero point 0.1 to 50 Hz. Okay, and I set my cutoff frequency of this high pass filter as 0.5 Hz. Then what this high pass filter is going to do, it is going to reject all the signals below the high cutoff frequency because it is going to allow the high frequency. That means the frequency above the cutoff frequency, right? So my cutoff frequency is 0.5 Hz, but the input signal is coming is between zero point 0.1 to 50 Hz. So what it will do, it will eliminate the signal between zero point 0.1 to 4 Hz, and at the output you are going to get a signal between zero point 0.5 to 50 Hz. Why? Because I had set my cutoff frequency as 0.5 Hz, so it is going to allow the frequency only above 0.5 Hz. It is going to reject all the signals below 0.5 Hz. So then I am going to get the 0.5 to 50 Hz. Okay, and let us consider this time I am getting low frequency right, but this time there is some noise in my high frequency. Okay, so what is the next case? 1 minute. So the next case is I am getting a frequency from zero point 0.1 Hz to sorry 0.1 Hz to 70 Hz. Okay, but I know that sorry 0.5 Hz to 70 Hz. But I know that I need a frequency of 0.5 to 50 Hz. That means you can know that above 50 to 70 it is a noise signal. So I need to remove that. Then I need a low pass filter. What the low pass filter is going to do? I am going to take a low pass filter. Okay, and I am going to set the cutoff frequency of this low pass filter as 50 Hz. Okay, that means what the low pass filter is going to do, it is going to allow all the signals below 50 Hz, and above 50 Hz it is not going to allow any signal, right? That means my input signal is having a frequency of zero point 0.5 to 70 Hz. Okay, but I had using having 50 Hz. Then what it is going to do, it is going to just allow zero point 0.5 to 50 Hz only. It is not going to allow signal above 50 Hz. Here the low pass filter is going to play important role. And sometimes there is a need for a notch filter, right? So why the notch filter is needed? So let us consider that I need only 50 Hz frequency and I want to just eliminate all the other frequency. Okay. Then I will use a notch filter. The notch filter just simply pick a frequency like 50 Hz, then it is going to just block the 50 Hz and allow all the remaining frequency like that. Okay. So this is about the filter, how the filters are going to work here. Okay. So yeah, the समझ में आया? Have you understood how the filters are working here? So बताओ, have you understood filters, how the filters are working here? How the filters are working? कोई है? सो गए सब लोग? नहीं देखे तो Rakesh. Have you understood how the low pass how the filters are working here? कोई है?
यस
Yes,
सर,
sir.
समझ आ गया सर।
ठीक है अपना दिया. Okay. Okay, then the next important part that we need to study is मेरा mic तो off नहीं है ना? सुनाई दे रहा है ना?
Yes, sir. सुनाई दे रहा है.
यस सर।
Okay, then the other thing that we need to learn here is next हो गया. Next we need to study about the uh, writing unit. Okay, let us move into the writing unit here. So and then I will explain that this part also. This is for analog type EEG machine and this is for digital type EEG machines. So let us move into the writing part here. आवाज आ रहा है ना? तो ये क्यों ये बार बार माइक की म्यूटेड बता रही है? आवाज आ रहा है ना आपको?
Yes, sir. आवाज आ रही है. म्यूट दिखा रहा है हम लोग को.
पता नहीं माइक म्यूट लिखा रही है लेकिन मेरा आवाज तो आ रहा है ना? चलो if I am not audible then let me know. Okay. Okay, so and let us move into the writing part. Okay, so if we are in the so what we are doing here, just we are going to discuss analog type of EEG machine. So what the analog type of EEG machine is going to do here? Okay, so 1 minute. So what the writing part is going to have, you are going to have a paper. Okay, so paper and pen. Okay, so this paper travel is going to move and this pen is also going to write upon that. Okay, that means the pen will also move and the paper travel will also move. Okay, but how the pen is going to move? The pen will move depending upon the depending upon your EEG signal. Okay, depending upon your EEG signal, the pen is going to but the paper is going to move with its constant speed. It is not going to fluctuate anywhere. It is going to move with a constant speed. Okay. So if you are going to see any older versions of EEG machine, then they are going to use the thermal recorders there. Okay. But uh, if you are going to use a pen type structure here, so the frequency of the pen is going to be 90 Hz. The frequency of the pen is going to be 90 Hz and some of the pens are going to also have a frequency response of up to 45 Hz. Okay, so how the pen is going to work? Okay, like the pen will be connected to the amplifier. Once you are getting the EEG signal from here, okay, you are getting EEG signal from the electrodes and then the channels will be selected and then it is giving to the amplifier and then the filter and then it will go to the sensitivity point and then it will go your pen. Okay, so pen is going to move according to an EEG signal. Like you blink your eye, suddenly the pen will move like this and then it will stay like this. And again you blink your eye, suddenly it will go like this, like this. So it will do like this. Okay, the pen will move like this and the frequency reference for pens is like that. Okay, and coming on to the modern type. So nowadays how they are coming, they will inbuilt with a laser printer. Just whenever the EEGs get completed, we are going to get a printed copy out from the laser printer. Okay, there is no need for any pen drive. So this particular writing part is just needed if you are using a pen and a paper. Okay, you are having a paper and you need to plot the machine need to plot a curve on the paper, then there we need a writing unit and paper unit. So the writing unit will be a pen, ink filled pen, and you need to regularly change in pen EEG signal. This will be stopping. Then the EEG is going to get on your paper. Okay, and then coming on to the paper drive. So okay, that means remember one thing, like your pen is moving like this, pen will only move in horizontal direction like this. Okay, so the pen is not going to move, sorry, the pen is going to move like this, upward and downward. It is not going to move in the right side or left side. Okay, the movement of the curve to right side or left side will happen because of the paper here. Okay, so what happens? Your pen will move up and down. Okay, and your paper will move in this right side direction. Okay, so first let me consider this is my paper. Okay, so initially my pen here, my paper here. Okay, so pen will plot like this, then paper will move forward, and then like this. Sorry, paper will move backward like this. In this direction, paper will move, and pen will first the pen will move like this. Paper will go back, face it like this. So paper will move continuously at a constant speed, and pen will move up and down, up and down. Then you are going to get a continuous plot like this. Okay. If your paper is not going to move, then your pen will move at only one single position, and you are going to get a curve like this. Okay, so the continuous recording curve will happen only when the paper is going to move in the left direction at a constant speed. Okay, so that means the paper unit is going to have some motor which is going to move the paper in the left hand direction at a constant speed. Okay, so they are going to use a synchronous motor or any DC motor which is having a speed. The speed will be 15 mm, 30 mm or 60 mm per second. Okay, so the paper will move like that. The paper will continuously move in this direction, and the pen will move in the pen is not going to move in the left hand side. It is going to just move up and down. It will move like this, up and down, up and down. The paper will move left side and the pen will move up and down. Then initially the pen will move up, the paper will move left, and then like this again paper will move left, like this, like this. So like this the curve will get plotted. That means there you don't think that the pen is moving. Pen is moving only like this. Like only position is going to move. The paper is moving, that's why you are getting a continuous plot on the paper. Okay, that means the pen will move according to an easy signal, and paper will move at a constant speed. That too, it will be moved by any motor. The motor may be a 60 feet, the speed of the motor may be 15, 30 or 60 mm per second. Okay, the paper will move 60 mm length for every second. Okay, so and then coming on to the channels. So the channels may be 32, 8 or 16 or more. Okay. So this is about the types adjustment for the analog type. So what about the digital type? Okay. So in the digital type, what happened here? Up to here, the unit is same. First, the ED will be captured electrodes, and then depending upon number of channels required, the montage selector is going to select the electrodes, and then the signal will be given to the amplifier, and then the amplifier is going to amplify the signal, and then it will be given to the filter, and then filter is going to remove the noise signal, and then it will not go to it will directly move into the analog to digital converter, right? Because the EEG signal is a time varying signal. That means it is an analog signal, right? So what the ADC converter is going to do, this converter is going to convert the analog signal into digital signal. Okay, and then once it converted to digital signal, you can display it on an oscilloscope, or you can display it on a computer. You can send it to a computer, and then computer will display the EEG wave on the monitor, and along with that it will store in a hard disk, right? And it can also be displayed on an oscilloscope. What is an oscilloscope? You can see the whole TVs where you can have a CRT tube, right? So the CRT tube is nothing but an oscilloscope type structure. That means this CRT tube is going to have an electron gun here. So this gun is going to release the what can you say, the cathode rays, and this cathode ray is going to strike with the phosphorus screen, and when this cathode ray is going to strike the phosphorus screen, so this wave will get distributed on the phosphorus screen and you can see the wavelet. Okay, so this is the oscilloscope. So the only thing that makes the difference from the analog to digital type is the signal will come to analog to digital converter. The ADC will convert the analog signal into digital type, and then it will give the signal to the computer, and then the computer will display it on the screen, or it will store in a hard disk, or it will display it on an oscilloscope. Okay, so this is the complete EEG block diagram. Okay, so let me summarize it. So in a very short way, so that you can remember all the stages. Okay, so let me erase all these things. So the first thing is you need a subject, because without the subject we are not going to get the EEG signal. So the first thing is you need a subject, and then you are going to place the electrodes on the head of the subject, right? And then these electrodes are going to capture the EEG signal, and then this signal will be electrode. Okay, channels you need. Okay, how many number of channels you need. Contact selector is going to group out the electrodes. Okay, and then it may be 12, it may be 16, it may be 32, or it may be 64 channels. That EEG signal will be given to this block. This block, first the preamplifier will be present. This preamplifier is going to amplify the signal. It is going to have an individual amplifier for each and every channel, and that too the amplifier will be a multi-stage. And then what you can say that it is a multi-stage differential amplifier with okay, and then it is having a high signal to noise ratio so that you can get the high signal and low noise. And then after amplifying the signal, this signal will be given to the filter. Okay, and what the filter is going to do, if you are having a noise at the low frequency range, then the high pass filter is going to come into the action, and it is going to remove the low frequency signal, and it is going to allow the high frequency signal. If you are having a noise at the high frequency, then low pass filter is going to come into the action, and it is going to remove the high frequency, and it is going to allow the low frequency. And if you are having a not single frequency noise, the notch filter is going to come there, it is going to remove the single frequency, and then it is going to allow the remaining part. Okay, and then if you are sensitivity selector, where you are going to select the sensitivity of the pen that is going to move, and then the signal will move into the writing unit. Okay, the writing unit is going to have two parts. One will be the writing unit, sorry, and then the other will be the paper unit. So writing unit will move in the up and down direction depending upon the EEG signal, and the paper is going to move in the left-hand direction at a constant speed. And the speed of the paper movement will be 15, 30, or 60 mm per second. Okay, and then if your machine is a digital type, then these two are not required. From the filter, the signal directly goes into an analog to digital converter. And what the analog to digital converter is going to do here is, it is going to convert the analog signal into digital type, and then the digital signal may be transferred to a computer, which will store the data in a hard disk. Along with that, it will display on a monitor, or you can directly display it on an oscilloscope. Okay, so this is about the complete EEG block diagram. Okay, so have you understood this?
Yes, sir.